The pace is quickening in the Aegis ballistic missile defense community. In December 2002, the President of the United States directed the Secretary of Defense to proceed fielding an initial ballistic missile defense capability in 2004 and 2005. This evolving integrated ballistic missile defense system, or BMDS, includes the Aegis ship-based element Aegis BMD, being developed by the Missile Defense Agency, MDA, to counter short and medium-range ballistic missiles and provide surveillance and tracking of long-range missiles in support of other BMDS elements. December 2003, the Aegis Ballistic Missile Defense Team prepares for Flight Mission FM-6, one of their biggest challenges to date, a significant step in preparing for the delivery of the initial Aegis BMD capability. The Aegis Ballistic Missile Defense System is under development. Using the proven technologies of the U.S. Navy's Aegis Weapon System, or AWS, built by Lockheed Martin, integrating components including the Standard Missile SM-3, built by Raytheon. The 2002 Flight Mission series saw 3 successful intercepts of a ballistic target out of 3 test attempts. In 2003, with FM-5, the Aegis BMD team was reminded of the challenges of ballistic missile defense. We increased the difficulty of the test, and although much went as planned, in the end we failed to intercept the target. The lessons of FM-5 were incorporated into the planning for FM-6. FM-6 also continues to push the engagement envelope. The FM-6 scenario calls for the firing ship, cruiser USS Lake Erie, to use its Aegis weapon system with its SM-3 missile to intercept a target during its descent in its mid-course phase of ballistic flight. This test positions the ship further from the target launch point than in any previous flight missions, over 300 miles, and presents the ship with a more stressing Ares target. Another first is the use of a cued target acquisition, where Aegis destroyer USS Russell, using its spy radar and long-range surveillance and tracking configuration, detects the target and cues the firing ship using a satellite link. This demonstrates that not only can an Aegis ship use its own radar for surveillance and detection of a target, as it has in past tests, but it can also use track data from other BMDS sensors, providing more operational flexibility and a team-like approach to ballistic missile defense. This tactical data link interoperability also demonstrates system capability to exchange data with other BMDS elements. Finally, the kinetic warhead, or KW, diverts in the final endgame stage to a specific lethal aim point at the payload section of the target. Aegis BMD has from the onset used an operational Navy ship and Navy crew to operate the Aegis weapon system and fire an SM-3 guided missile. In FM-6, for the first time, the challenge is to increase the use of operational procedures to engage and hit a ballistic missile target without advance notice of target launch time. As in previous tests, Lockheed Martin, the Aegis Combat System Engineering Agent for the Navy's Aegis Ballistic Missile Defense Program Office, coordinates activities across the FM-6 team to ensure program success. Activities at Lockheed Martin's Maritime Systems and Sensors includes continuing development of the Aegis Weapon Systems Engagement Computer Program for the Aegis Cruiser and the Surveillance Program for the Aegis Destroyer. Changes to the computer programs are tested at the U.S. Navy's Combat System Engineering Development Site, CSEDS, and Lockheed Martin's Computer Program Test Site, CPTS, in Morristown, New Jersey. Also using CSEDS and CPTS for 3 days in October were combat system teams from USS Lake Erie and USS Russell, practicing and rehearsing using a simulated link environment in preparation for FM-6. The computer programs used for FM-6, the first of 3 Block 2004 deliveries, are the foundation of the programs deployed in the Aegis BMDS initial defensive operation. And in Elkton, Maryland, at Alliant Tech Systems, ATK, testing continued on Raytheon's KW with a new monolithic valve design in its solid divert and attitude control system, SDAX propulsion unit. The KW is now aimed at a lethal point on the payload section of the target. To assist in post-mission lethality and impact point assessments, the FM-6 target carries a reactive payload with a hit point instrumentation grid in its nose cone section. For the FM-6 mission, Russell plays an integral role as the surveillance ship, detecting the ballistic missile and forwarding tracking data to firing ship Lake Erie. This mission ushers in the newly developed surveillance program, or SURV 1.2. Preparing for SURV 1.2, cooperative grooming of the Aegis weapon system with engineers from Port Hueneme and Lockheed Martin is performed along with necessary system assessment and modifications. Modifications to the UYK-43 computers, signal processor, and new command and decision adjunct processor enhances Aegis weapon system operation, improving system confidence and demonstrating the performance capability of the SURV 1.2 computer program. Aegis destroyers with the Block 2004 30E program, which includes Surveillance 1.2 capabilities, form the basis of the initial Aegis contribution to the President's Block 2004 BMDS directive. After the test ship USS Lake Erie returns from underway waterfront integration testing, an SM-3 missile is loaded into its designated cell of the vertical launching system in preparation for FM-6. Before FM-6 proceeds, an MRR, Mission Readiness Review, is conducted to make sure all is ready for the test to begin. Assembled at the MRR is the Aegis Ballistic Missile Defense Team, government, military, and all the industry organizations that make the Aegis Ballistic Missile Defense System work. It's a team with technical depth, strength, and experience. December 8, 2003, USS Lake Erie CG-70 and USS Russell DDG-59, with their officers, crews, and Aegis Ballistic Missile Defense Test Teams, depart Pearl Harbor, Hawaii for the Pacific Missile Test Range. As in previous tests, flight mission missile defense tests are executed by the officers and crew at their battle stations, assigned to in-service Navy combat ships USS Lake Erie and USS Russell. Now the captains and crew, along with the government civilian test teams, get ready for their biggest challenge to date, FM-6. Some 340 miles off the Hawaiian island of Kauai is the firing ship USS Lake Erie. The crew is at Space Warning Condition Yellow readiness for a hostile ballistic missile firing. Also waiting uprange at more than 100 miles northeast of the island of Kauai is the surveillance ship USS Russell. Another FM-6 objective is mission interoperability, with Russell acting as a remote detection sensor along with other BMDS assets. The surveillance ship is closer to the target launch point and will initially detect and track the target with its Spy-1 radar. Russell will then transmit this track data over a satellite to Lake Erie and also back to BMDS locations in the U.S. Lake Erie will then process the queued acquisition track from Russell to direct its Spy-1 radar search volume on the target and forward this data back to BMDS. One of the ships will respond to BMDS data update requests. Extensive optical sensor systems, video, audio, film, and instrumentation data is on hand to document FM-6 and collect engineering data to assess system performance. The video and audio displayed is from actual testing data. After a series of increasing threat levels, Lake Erie and Russell receive their latest intelligence reports. Set Space Warning Red, weapons tight. They are at the highest stage of alert for a ballistic missile launch. They will get no countdown. They have to be ready to react to hostile actions and detect a launch. On the PMRF launch pad, an Ares ballistic missile test target undergoes final countdown. Lake Erie Ship's force, using the Aegis weapon system, sets up a queued acquisition doctrine in preparation for receiving Russell's target queue data, preparing for target engagement with their SM-3 missile.
7, 6, 5, 4, 3, 2, 1.
A side-mounted video camera on the Ares target provides a view as it climbs above the atmosphere and into space. The Aegis weapon system on Russell detects the target as it breaks the radar horizon while still in its boost phase.
All stations RC space track 2047.
TOI, evaluate 2047.
TORC confirmed fireball track 2047.
Seconds later, Russell transmits the Ares track information over Link 16.
All stations, fireball, 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 track 2047.
Attack control, deck is clear.
Track information is received almost instantly by Lake Erie, and a queued acquisition volume is initiated.
Receiving queued acquisitions.
Launch radar alert, GM on.
After the set space warning red weapons free is announced, the commanding officer releases the batteries in preparation to fire.
All stations, Captain. Batteries released. Business green. Break control.
Control eye.
All stations, Genesis, track 2051.
The Spy-1 radar transitions to target track, and precision information is distributed to the Aegis weapon system.
Fireball, 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 track number 80142.
Shortly after target detection, Spy-1 radar processing determines that the target is in its ballistic flight phase. Having activated Battle Short, the Combat Systems Coordinator initiates the engagement order to the Missile System Supervisor, or MSS, to fire the SM-3 missile.
Engagement sent.
The SM-3 missile is selected by the MSS, and fire authorization is enabled.
Stand by, fire authorized in 4, 3, 2, 1.
Prior to launch, the SM-3 missile is initialized with GPS data and position and velocity data for the target and the missile.
Eagle way.
Within seconds, the Spy-1 radar system acquires and tracks its SM-3 missile.
All stations, Captain. This is red.
Control eye.
Good phase, one uplink.
All stations, Lake Erie, Eagle track 1005.
Acceleration commands are computed by the Aegis weapon system and transmitted to the SM-3 missile via spy radar uplink message data, keeping it on a target intercept path. As the SM-3 flies toward the target, 3 important steps occur. The second stage burns out and separates. The Aegis weapon system updates the missile with both the missiles and the target's position and velocity data. And the missile uses that data to perform the first of 2 third-stage pulse burns.
Pulse 1 burnout.
The duration of burns between SM-3's third-stage rocket motor, or TISRM, known as the interpulse delay, is calculated by the Aegis weapon system and provided to the SM-3. While coasting, the missile performs a pitch maneuver and ejects the nose cone.
50 seconds.
Nose cone eject. Pulse to ignition.
The second pulse burn performs the final velocity increase and course correction, placing the missile on a collision course with the target.
Pulse 2 burnout.
At completion of the second pulse burn, the third stage attitude control orients the missile so that it points at the target.
KW eject.
With spy radar accuracy, the Aegis weapon system is able to put the target dead center in the SM-3's field of view. Shortly after ejection from the third stage, the KW acquires the target.
KW track.
10, 9, 8.
The square around the target image indicates that the target is now in track and KW divert guidance has commenced.
1.
Yes!
Mark India.
It's a direct target hit. For the first time, the kinetic warhead impacts the Ares target at a lethal aim point. The target is destroyed. FM6 is an excellent data gathering opportunity, providing clear views from a variety of optical sensors, showing clearly the lethal Ares target destruction by the SM-3. Here is a slow-motion replay of the target impacted by the KW. This view, recorded by the Halo airborne system, shows the clearly visible SM-3 third stage. Here is the KW, and here is the Ares target. The explosion is evidence of the KW impacting the target with its reactive payload, while the third stage continues to fly to atmospheric re-entry. After intercept, the spy radar on Lake Erie begins initiating track on numerous debris objects, providing an Aegis real-time indication that intercept has been achieved. The surveillance capability demonstrated by USS Russell supports 2004 initial defensive operations, providing important ICBM long-range surveillance and track data to the BMDS. Also, the importance of an interoperable system transmitting real-time Link 16 target data to BMDS and other assets is successfully exercised. Watching the FM6 event live over the Lake Erie PMRF video conference link, MDA, the test team in Hawaii, and others throughout the ballistic missile defense community countrywide experience another program success. The test team is ecstatic, but well knows that the rigorous analytical work only continues. Immediately, test data gathered by the various sensor systems is scrutinized for system improvements and inclusion in support of the next test event. As demonstrated with acute acquisition from external sensors, the precision fire control and guidance accuracy necessary for a ballistic missile intercept is repeatable with the U.S. Navy's Lockheed Martin-developed Aegis-equipped system. And for the fourth time, a kinetic warhead impacts and destroys a ballistic missile target, this time with a lethal KW aim point in mid-course phase. For FM6, mission accomplished. These results validate the direction and progress of the Aegis Ballistic Missile Defense Block 2004 program, pointing the way in the near future when the responsibility of fielding the Aegis Ballistic Missile Defense System will be met as part of the new Ballistic Missile Defense System, protecting our nation, allies, and combat forces, making ballistic missile defense a reality.